Okay. So, and here, for example, in this image, you might see the different parts of the, oh, okay, hopefully yes, it starts to record. So you see here this in your questionnaire, there's different parts of blastocyst might be indicated with the letters or with a or number, and the question might be, for example, what is indicated with the number 1 or 2 or with the letter A, and you have to know that which part this blastocyst contains. You have to know the main steps which the zygote goes through the first week, second week, third week. Okay, these main steps, main stages of development. So zygote during the first week reach the stage of morula, then morula start to implant, then morula, and by the way, morula is transformed into the blastocyst. So zygote, morula, blastocyst, which then give rise to the two bilaminar embryonic disc, then trilaminar, then the three germ layers start to develop and gives rise to the almost all organs during this third to 8 weeks period. Okay. Um, Also might be, for example, in your questionnaire included this schematic image. And again, what is indicated with uh, a, or what is indicated, what type of cells are colored green or something like this, or for example, what type of process is depicted on this image, on image C. What type of process is depicted here? This is when the blastocysts start to penetrate the epithelial lining of uterus. Yes. So, or start to penetrate the uterine mucus is written here. So it depends on how the right answers will be formulated in the multiple choice question. Do you hear me? Everything is clear. Everything is understandable. Okay, so let's go further. You see here no clinical correlations at this step, okay? And um, pay attention to the pages which we need, which are indicated in your syllabus. So, what is here? What is depicted here? Human blastocyst. If you remember the day, excellent. If not, please try to remember the week when it happens, at the beginning of the second week or end of first week. So at the end of first week and beginning of second one, the human blastocyst is partially embedded. Yes. And what parts it has? You have to know that all these layers because they might be indicated, and again the questions, or um, it might be, for example, the collage or several pictures, figures might be included in one image, and you have to identify for, and the questions might be, for example, in which of them the implantation process is, initiation of implantation is depicted, or for example, in which of these 4 or 6 micrographs or schematic images is depicted process of formation of bilaminar embryo or trilaminar embryo, something like this. Okay, so that is why please pay attention. I wrote in the syllabus to pay attention to the figures, of course. This is the real sample, as you know, and you can see here human blastocyst with a quite big amount of syncytial trophoblast. Look, whole this layer is syncytial trophoblast, this one, with a lacunae. And here you see also the embryo itself. Look, this one here, with a cavity, blastocyst cavity, with a two-layer amniotic cavity. Look, the thin mm, cleft. This is embryo amniotic cavity. Plus, you see here layer of cells, epiblast and hypoblast. I'm talking about these layers. Okay, so this thin cleft, which is amniotic cavity, epiblast cells, hypoblast cells. What type of cavity is this? Blastocyst cavity, of course. And you see this two population of the cell, which is derived from the trophoblast. So this is syncytial trophoblast and cytotrophoblast layer. Okay, so the same is here. Syncytial trophoblast, cytotrophoblast. Look, this one here. Epiblast, hypoblast, cavity, blastocyst, and amniotic cavity here. Okay. So then, how the primitive yolk sac is formed? So the sign that primitive yolk sac start to form is uh, appearance of new population of cells. Look, this yellow stained cells, this one, which is derived from hypoblast cells. And when this blastocyst cyst cavity became lined with these cells, it is transformed into the primitive yolk sac. Okay, so primitive yolk sac. What we have here, you see, what is this? This is the trophoblast, cytotrophoblast cells, syncytial trophoblast cells. We have here epiblast cells, hypoblast cells, amniotic cavity. And what is also important here, that this small cavity, small spaces start to appear in the syncytial trophoblast, and they give rise to the lacunae, trophoblastic lacunae. And later, you see here that this in this stage, you see the enlarged blood vessels in the stromal part of uterine wall, and then this they became they fuse with the lacunae here, and maternal blood, maternal sinusoids, and this lacunae form the continuum. So continuum means when the connection between them is established, and no difference at this moment. I mean, at the connection point is identifiable between these two structures, sinusoid from one part and lacunae from another part, but actually these are two different structures. So continuum is formed here, and uteroplacental blood supply start to initiate here. Besides, you see another population, new population of the cells, which is formed partially from the hypoblast cells, from this lining of primitive yolk sac, and plus you well, from also by the participation of trophoblast cells. Trophoblast cells also participate in formation and in the development of this layer. And what is this layer? This layer actually is extra embryonic mesoderm. Please remember extra embryonic. What kind of mesoderm we have later? Which kind of mesoderm will develop in the embryo? Do you remember? Besides this extra embryonic mesoderm, intraembryonic real mesoderm, which is one of the three germ layers of the embryoblast, of the embryo, trilaminar embryo. So what you see here, you see this layer, this brown stained layer of the cells, which then step by step is vacuolized. The small spaces are developed here. Formation of this layer together with the is the overlap process with the formation of vacuolization, formation of the small cavities. Then the small cavities fuse each other and they give rise to the what? Which type of cavity is formed later here? From these small spaces, which type of cavity is formed in extra embryonic mesoderm? Can you write me? Amniotic cavity is this one. We have here, do you hear me? What type of cavity is derived or originated in the extra embryonic mesoderm? And here might be listed three possible right answers: amniotic cavity, yolk sac, primitive yolk sac, chorionic cavity. Which one? Guys, which, do you hear me? Yes or no? Do you hear me?
Yes.
What type of cavity is formed in the extra embryonic mesoderm? Chorionic cavity.
Sorry, doctor. We write for you, but that not shown.
One, maybe amniotic cavity. So chorionic cavity is formed, and the look, chorionic cavity, and this is the yolk sac became much more smaller, and it is transformed into the secondary yolk sac, and the chorionic cavity became lined with the extra embryonic somatic mesoderm, this one. But this one, I mean, the surface of primitive yolk sac, amniotic cavity, is lined with the with another layer of extraembryonic mesoderm, splanchnic mesoderm. Okay, this one here. and only this small part is still left as a whole, without any lacunized, without any spaces or cavities, which is a real stock, connecting stock. And this connecting stock gives rise to the umbilical cord later. Okay? So simultaneously, the oropharyngeal membrane is formed here. So oropharyngeal membrane, and a little bit later, cloacal membrane here. But before, during the third week, what is happened with the surface of um, epiblast layer? What is happened here? So at the beginning of third week, the primitive streak start to develop. Yes. Now it is not visible, of course, here, but later you know that this primitive streak is very important because it actually determines the ends, I mean cranial and um, caudal end of the embryo, and plus cranial end and caudal end, and plus the cells of epiblast start to migrate. Okay, so what is this? This is exocelomic cyst, which is derived from primitive yolk sac, pinched off from primitive yolk sac. And here you see this lacunae filled with the maternal blood, and no clinical, we do not need clinical correlations at this step. And now we go to the third week of, again, the third week of development, trilaminar germ disc. And the pages, all pages are indicated here, which you need. Okay? So it might be the, for example, third week of development, trilaminar germ disc. And first topic is, this is whole title of the whole chapter, this one. Hopefully you understand this. And the subtopic which you need is indicated here: gastrulation, formation of embryonic mesoderm and endoderm, formation of the notochord, and pages are indicated. So what is happened here? What is here? Look, this is section through the embryo, and this is bilaminar embryonic disc. We have here how many cavities you can identify on this image. Amniotic cavity. Do you hear my voice, guys? Is everything understandable what I say? Please
Yes.
write me, okay?
Doctor, you can go down in the chat to see our what we say, or what we write.
Say it again, please.
Go down in the chat to see what we write, to see the answer, what we answer you for you.
Okay, down, you mean in the
Go to the
chat?
chat.
In the chat,
Yeah,
yes? So,
yeah,
okay, just a minute,
yeah.
just a moment.
And you see our answer.
Okay, yes, So, Korean. Okay. Thank you to remind me to go down. I forget to move. Okay, thank you. So, how many cavities? Three. Some of you say two. Three is correct because you see here uh, one amniotic cavity, yolk sac, and part of chorionic cavity. Okay? Part of chorionic cavity. Chorionic cavity should be here, but only small part is visible here. Okay? So, what is here? So, another layers. This is syncytial trophoblast, cytotrophoblast, and extraembryonic mesoderm here. And the surface of the epiblast is represented on this image. Yes, hopefully this everything is clear. And here should be amniotic cavity, but it is removed now. Here should be primitive secondary yolk sac, and it is removed from here. And layers of bilaminar embryo are clearly indicated. Hypoblast stained blue and epiblast stained blue and hypoblast stained yellow. So on the surface of epiblast, you can identify this primitive streak and oropharyngeal membrane. What does it mean? It means that this part is cranial end and that part is caudal end. Hopefully everything is understandable. Yes? Am I right?
Yes.
Okay, excellent. In this case, we can go further and you will see here the arrows on the surface of epiblast. What these arrows indicate? They indicate directions of movement of cells, migration of the cells, and which type of migration is determined formation of the trilaminar embryo, migration of the cells beneath the primitive streak. Yes, and this first wave of migration gives rise to the layer of the cells which occupies this central portion of hypoblast. And these hypoblast cells are pushed to the periphery. So these cells occupies these cells migrated from the epiblast. They occupy the central portion of the hypoblast layer, and endoderm is formed. Okay, so another wave of migration is when the cells migrate and occupies the middle, I mean, space between the epiblast and endoderm, and they give rise to the mesoderm. And finally, the rest of cells in epiblast layer, they give rise to the ectoderm. And as a result, trilaminar embryo is formed. What is the difference, difference between these and that sections? What type of section is this one and what type of section is that one? Of course, these are schematic images of the trilaminar embryonic disc, but they are represented, their profiles are represented in different plane of section. So this is, yes, exactly, sagittal section. This one is sagittal section, and that one is That one is frontal, transverse section, but frontal, yes. So that is why here you can see the what structures you can identify here. You can identify here ectoderm, you can identify here mesoderm and endoderm, and in the mesoderm itself, you can see the precaudal mesoderm, which gives rise to the precaudal plate, notochord itself, and small part of mesoderm. Also, this neuroenteric canal, which binds the amniotic cavity with the yolk sac, is clearly visible. So oropharyngeal membrane is also identifiable here, and allantois. What is actually allantois? You have to know the allantois. You have to know or how it looks like on the schematic image, because, for example, the question might be formulated in such a way: please identify what is indicated with the A, and with the A here will be indicated the allantois, or with the A might be indicated, or with the B might be indicated here the oropharyngeal membrane. Okay, so here you can see notochordal plate. This is transverse section, but you can't see here not oropharyngeal membrane and not allantois or the caudal end of the trilaminar embryo, trilaminar disc, embryonic disc, because this plane of section goes somewhere here or there. Okay, so that is why you can't see here this cranial or caudal part. This is cross section somewhere in the middle. So here is the process of formation of the notochord, and here notochord is already formed. So please remember, you have to know what for notochord is needed, why notochord is very important for further development of the embryo. Okay, what type of structures or what type of organ system is developed as a result of induction, which is as a result of notochord induction. So notochord induced formation of what? Of what? Do you remember what is formed?
Nervous system.
Nervous system. But before nervous system is formed, what is formed in the ectodermal plate? In the ectodermal layer. Not neural tube. Okay, neural tube, the brain. The answers are the brain, neural tube, spinal cord, neural plate. Exactly, neural plate. First step should be, as a first step, should be formed neural plate. Do you know the different parts of mesoderm, which are developed later? So this layer of mesodermal layers start to differentiate and gives rise to the three different parts of mesoderm. So paraxial mesoderm, intermediate mesoderm, and also the lateral mesoderm. Hopefully you know this. So also the notochord is formed here, and beside the notochord, what you can identify there, you see the different, what is indicated on this image, what is represented on this image. This image actually demonstrate the fate of cells allocated in different parts of epiblast layer. So this is surface of epiblast. This is notochord, primitive node, oropharyngeal membrane, and cloacal membrane. So all these cells, they after proliferation, they start to move, they start to migrate. This layer of the cells, I mean, this population of the cell, which is allocated at the most cranial end of primitive streak and the primitive node, it moves forward and gives rise to the notochord. So the cells which are allocated on this part right next to the notochord, on both sides, they give rise to the mesoderm. They move forward, and by the way, they differentiate and give rise to the paraxial mesoderm. So this population of the cells and that one, okay? The next population of the cells, which also start to move beneath the epiblast and form the mesoderm, they form intermediate mesoderm. Then the next population of the cells forms the lateral plate mesoderm, and finally this this one. This is cell which gives lining to the chorionic cavity. Mesoderm, which actually forms the chorionic cavity. Of course, this is extraembryonic mesoderm. Okay. So here the question might be, for example, they might be numerated or indicated with the letters, and the question might be what type of cells or what type of structure is developed from the population of the cells indicated with a A. And with the A will be indicated this one or that one, with the B, C, D, etc. Something like this, okay? So no clinical correlations. Again, you know this image already quite well. And also, you have to know the structures of the villi. So these are villi in the different stage of development, of course. And look, here we have it depends on the plane of section initially, and also it depends the structure depends on the differentiation of the cytotrophoblast cells. You see here that the primary villus contains the syncytiotrophoblast. It is surrounded with the syncytiotrophoblast. Look, syncytiotrophoblast is dark green and contains only the cytotrophoblast cells. Later, when this extraembryonic mesoderm become much more well developed, and it moves much more deeper in these protrusions and gives rise to the such type of structure, I mean secondary villus, which contains the syncytiotrophoblast cells, cytotrophoblast cells here, and the core contains extraembryonic mesoderm. And later, when in the extraembryonic mesoderm, you can identify the capillaries, which are called villous capillary. So it means that this part, this villus, is reach the final differentiation. It forms the tertiary villus, and tertiary villus contains the blood vessels, blood capillaries. Look, like here and or there. And they actually finally provide formation of the uh, capillaries in the mesoderm, and they give rise to the umbilical cord vascularization. Okay, blood supply. Okay, so the another topic here is the 3 to 8 weeks, and this is the embryonic period when the different parts, different organ systems start to develop. And you have to know the main events of this third week of development. And plus, you have to know, for example, which organ system is derived from the ectoderm, mesoderm, different parts of mesoderm, and endoderm. Okay, so first of all, what has happened with the ectoderm? So ectoderm gives rise to the neural plate. Yes, look, the neural plate. In the cranial end, it is much more wide type of structure, this plate. Caudal end is much more narrow, but anyway, this is a plate which is developed from the ectoderm, and this is neural plate. And in development of neural plate is induced by the notochord. So you see here, this is real embryo, and you see this plate here. You see the primitive streak and groove, neural groove. I think with these images, everything is clear. And what is depicted here, what is the difference between this stage on 19 days of development and that one? Of course, formation of the somites. And somites are formed in which layer of trilaminar embryo? Which layer gives rise to the somites? Can you write me? Or tell me, please, which layer gives rise to the somites? Mesoderm, of course. Mesoderm. And mesoderm, correct. And they are differentiated in, look, this somites became much more and more appear on the surface. Of course, you understand that this is dorsal view of the embryo, and the amniotic cavity is removed. That is why you can see this surface. The same is here. This is dorsal view, and here you can see the lateral view. Plus, what are these holes left which connect the after the closure, after the fusion of these folds? Neural tube is formed, and at the cranial end and caudal end, the neuropores are derived, left. And these neuropores, what for these neuropores are? They connect the neural tube lumen to the which cavity? Amniotic cavity. Okay. Later, of course, these pores became closed, and the closure finally means that the neural tube is finally closed. So here you see the already this anterior neuropore and posterior, and here on the at the end of fourth week, you see that the anterior neuropore and posterior, they totally disappear. But what you can identify here is somites. You can see the cranial end, which contains placodes, lens placodes, otic placodes. Placodes means thickening, you know, and this is real ectodermal thickenings. So the lens placodes give rise to the eye, otic placodes gives rise to the ear, some part of the ear, and here you also see the pharyngeal arches. So what pharyngeal arches are? Pharyngeal arches are, they contain mesoderm, of course, and they are covered with the ectoderm, but at the same time, these pharyngeal arches are finally became clearly visible and identifiable when the before the closure of neural tube, neural crest cells migrate in it, and they became, these roads of mesoderm became much more thicker, and the indentations appear between these roads. So these indentations are called pharyngeal clefts, but actually these are not real clefts. These are, they looks like more as a grooves. And you also, so what are the neural crest cells? You have to know what neural crest cells are. So they are derived from neural ectoderm, I mean edges of neural folds. So these are folds. And this is groove, neural groove. And this population, which is allocated at the edge of neural folds, uh, they give rise to the population. They are differentiated into the neural crest cells. And in the trunk region, after the neural tube is closed, they start to migrate, but in cranial part, before closure, they already start to migrate. And as a result of their migration, is occupation of different places. For example, they give rise to the sympathetic ganglion, and they give rise to the suprarenal gland. They start to occupy the enteric ganglia, and they also start to move into the ectoderm and give rise to the pigment cells. So a lot of cells are derived, different type of structures. I mean, cells are differentiated from neural crest cells. That is why they are considered as a fourth germ layer of the embryo. So you see here, look, the arrows, and these arrows actually depicts movement, migration route of the neural crest cells in the cranial part of the embryo. This everything is happened before the closure of neural tube. So and they migrate into these roads of mesoderm and road-like structures, and they became finally thick, and this indentation between these roads appear. So they give rise to the, everything what I can't speak simultaneously about all the processes which are developed here. Of course, I speak about them in some sequences, but you know, actually, all these processes are overlapped. I mean, in time frame of in which they are developed. Okay, what is written here, please? What is the difference between the pharyngeal pouch and pharyngeal arch? Okay, I will explain this. When I go to the endoderm, okay, when I go to the gut tube formation. So okay, I will tell you now. The pharyngeal arches, they are developed from the mesoderm plus neural crest cells, and they are covered with the ectoderm. So together with the neural tube formation, the endoderm, look, I will show you this image. Uh, Endoderm rolls and gives rise to the gut tube. So actually the gut tube is formed from the endoderm. And this gut tube gives rise to the pouch-like structures. Look, I will show you this. Here is depicted the transverse section through the trilaminar embryo on different stages of development. Here is all three layers are already formed, but mesoderm is not segregated in different parts. Here it starts to differentiate mesoderm, and at the same time the neural folds are formed here, and mesoderm gives rise to the paraxial, intermediate, and lateral mesoderm. And in the lateral mesoderm, look, the small cavities start to develop. So the small cavities fuse each other, and this is the actually this is preliminary. This space gives rise to the intraembryonic cavity. Okay, intraembryonic cavity. Look to this cavity. This is the real body cavity. Okay, this one. And at the same time, you see that the endoderm rolls step by step, and the connection between this small space here and that, this part of yolk sac and that part became narrow and more narrower. And when finally the neural tube is formed here, look what has happened with the endoderm. Endoderm gives rise to the, look, to the gut tube. And gut tube later, look, gut tube is formed, and this gut tube gives rise to the pouches. Look, actually, pouches, they looks like small pockets on both sides of um, gut tube. I think here is another image which is much more clearly depicts this gut tube pouches. Wait. No, not here. Okay, I have it in my presentation, and I will show you this one. Wait, guys, I will go to the presentations. Okay, where is this? No, no, empty. This is empty folder. What? Okay, it should be here. Look. No, I do not like these images. Another one. Um, no, the patches are not depicted here. Okay, wait. I think we have time, so I can. Um, so look on this image here. Are depicted these porches too, but not so well as in other case. No, not this one. Look, this is gut tube here. This is foregut, midgut, and hindgut. So you see here this, look, the small protrusions. And these are actually, they give rise to the pouches, these small protrusions on the both side of gut tube. And these small protrusions on the both sides, they form the pouches. Look, this one. This is in your textbook also, but I have used another image. Unfortunately, it is not included in these presentations. Okay. So these, on both sides of the gut tube, the small pharyngeal pouches are developed. These pharyngeal pouches are actually beneath the pharyngeal arches, but they do not give rise to the clefts. So at the they do not directly fuse with the ectoderm. This is actually endoderm, and the pharyngeal arches are covered with the ectoderm. So look, please. Okay. Is understandable this situation with the pharyngeal arches and pharyngeal porches. What is the difference between them? So pharyngeal arches are derived from the mesoderm, ectoderm, and neural crest cells, and pharyngeal porches are derived from the endoderm. Okay, so what we have here. So this chapter, I mean, gut tube and body cavities, we do not need at this step, okay? Only derivatives and process formation of organ systems between the third and eighth week. So when the neural tube is formed, neural tube is formed, they is still information in the process of fusion. I mean, neural folds. This endoderm rolls and gives rise to the gut tube. But you have to understand here one thing: folding. What is the folding process? Look, folding process is indicated here with the arrows, or here, for example. Okay, look, this is process of lateral folding, left and right folding. Okay, and this fold, due to the cell proliferation, due to the migration of the cells, it moves down, and this small cavities between this parietal and splanchnic layer or visceral layer of mesoderm, they give rise to the lining of the intraembryonic body cavity. Okay, so look, this is body cavity, here is body cavity 2. In the middle part of the embryo and in the cranial and caudal part, this process of foldings goes in different way. So in the middle part, these lateral folds fuse to the wall of chorion, of yolk sac, okay, and they to the yolk sac. But in cranial, more cranial part and more caudal part, where the this yolk sac is not represented, they fuse with each other and give rise to this embryonic body cavity. Okay, so this has happened in cranial and caudal end of the embryo. Such fusion with the yolk sac happens in the more middle part of the embryo. Look, look, this this was lateral folding, yes, left and right. But this is folding, craniocaudal folding, when the embryo grows and it undergoes folding itself, and due to this folding, look, it folds down this cranial end and caudal end, and cause folding of the cranial part of this cavity and here. That is why they also here fuse with the yolk sac and give rise to the cavity of gut tube. Look, gut tube is this one here, and it gives rise to the lung bud, and it gives rise to the pharyngeal pouches here. Here is the allantois, which became allocated in the later into the umbilical cord finally. And but here this membrane gives rise to the cloacal membrane, gives to the anus. So, and this connection between the midgut and yolk sac became narrower, but connection still is represented. So this is middle part of the embryo, okay? Cranial end and caudal end. They fuse with the wall of yolk sac, and here in the cranial part, uh, they form the face and head. Finally, head and neck is formed here. So, and in the embryo itself, you can see this pharyngeal pouches, esophagus is differentiated. Also, the liver start to develop, and the umbilical cord is finally formed. And umbilical cord here contains the vitelline duct and allantois. Vitelline duct, which connect the uh, midgut with the yolk sac. Yolk sac then degrade later, and also the allantois is here. Do you remember initially allantois was um, directed into the, look, where is this layer? Can I see it here? No, not here. It was as a protrusion of endoderm into the connecting stalk. Then, by due to the folding, it moves. It moves down, and then together with this vitelline duct, they are incorporated, included both of them in the in the umbilical cord. So vitelline duct and this allantois. Okay. So allantois is derivative of endoderm. So what is everything understandable what I tell you here? Okay, please write your questions here. Please, what is the difference between the pharyngeal pouch and pharyngeal arch? Or okay, with the pharyngeal pouches and pharyngeal arches, everything is clear. So the ectoderm gives rise to the neural nervous system. Yes, and gives rise to the crest cells, population of the crest cells, and this population of the crest cells is involved in the formation of melanocytes, different type of neurons outside the nervous system. I mean, different type of ganglia, sympathetic of autonomic nervous system. Plus they give rise to the they form the pharyngeal arches, and these pharyngeal arches participate in development of uh, the face, head, and also they participate in the for information of different parts of ear, for example. They give rise also to the nerve cells in enteric nervous system, enteric innervation. They give rise to the cells of adrenal cortex, etc., etc. So a lot of here. The main thing is that you have to understand how this cells are developed. I mean, crest cells, and how this foldings at this moment. I mean, at the moment of gut tube formation takes place in the embryo. So lateral folding. This is lateral folding, and also we have here craniocaudal folding. Okay. So also important, you have to, the mesoderm gives rise to the blood vessels too. So the blood vessels, they might be derived from the existing already differentiated blood vessels, or from the population of mesodermal cells, which are actually the hemangioblast cells, and they provide formation of tube, and this small tube is blood vessel, of course. And then, by the way, this hemangioblasts, they give rise to the blood cells. So this is development of the blood vessels and blood cells from the mesodermal cells. But this already formed, already differentiated cells, they might give rise, they also differentiate further and give rise to the new blood vessels by the branching, by the elongation, by the proliferation of the cells which lines this inner and outer surfaces of blood vessels. Okay, so, and finally, as a result, you see here small part of placenta, and you see here the villus, villi actually, and how the this is heart here, and how the blood start to reach the embryo itself. So the blood capillaries, blood and blood cells, they start to develop first in the yolk sac and in the liver. Then uh, the liver is the major blood forming organ during the embryogenesis. Okay, so and endodermal germ layer gives rise to the gut tube, and this gut tube gives rise to the pharyngeal pouches, and then diverticulum of the lung. Then lung buds are formed. So the it gives rise, endoderm gives rise to the epithelium, to the epithelial lining of the visceral organs. Okay, so these are the main figures, main topics which will be included. So intermediate mesoderm, I forget to tell you about the intermediate mesoderm. Intermediate mesoderm actually gives rise to the nephrogenic cord, and this nephrogenic cord gives rise to the all urine structures of urine system. So you can see here, for example, no, not here. It is not depicted. This, okay. Oh, okay. So the paraxial mesoderm. So with the parietal and splanchnic layer, we see that they give rise to the lining of body cavities, serous membranes, and plus they give rise to the endodermal epithelium, which lines the um, inner surfaces of cavities in the body, and plus, for example, the epithelial lining of gut tube, epithelial lining of respiratory system, I mean lungs. But what is the intermediate mesoderm gives rise to the kidneys, and but what is happened with the paraxial mesoderm? So the paraxial mesoderm is mesoderm which is allocated right on both sides of the neural tube. And this is actually the type of mesoderm which is transformed first to the epithelial cells, and then later they are again transformed into the mesodermal cells. But when they are transformed into the epithelial cells, they give rise to the sclerotome cells. And the sclerotome cells are cells which are represented on both sides of neural tube, of course, and these are the cells which differentiate into the skeleton. Okay, so different type of bones. And plus we have this mesoderm also differentiate into the dermatome, which gives rise to the dermis of the skin layer later, and ventrolateral and muscle cells, which gives rise to the back muscles and muscles of the limbs. Okay, and here we see the notochord, which is very important because it induces the formation of neural plate, and then neural plate undergoes folding, and neural folds are derived. In the middle, the neural groove is formed, and this is the whole process of neurulation. And here you see already formed neural tube, neural tube, and myotome, which gives rise to the muscles, sclerotome layer, which gives rise to the bones, ribs, etc. This sclerotome, and you see the dermatome, which gives rise to the dermis of the back skin. In the wall of neural tube, the cells differentiate and gives rise to the neurons. But at the same time, from this part here are migrating the crest cells, and crest cells give rise to the cell population of crest cells, which moves into the skin. They give rise to the melanocytes, melanocytes allocated in the skin, in the hair follicles, in epidermis, in hair follicles. Uh, Also, you can see them in eyes too. And what we see here, this is the layer of oh, okay, about myotome, I already told you that they give rise to the muscles, different type of muscles. Part of these myotomal cells migrate into the parietal mesoderm and gives rise to the muscles of the um, limbs, and another gives rise to the intercostal muscles. So, okay. Hopefully with the folding is everything clear. Yes. Do you understand how this folding takes place? Okay. Now, guys, maybe you have questions. Okay. What about the new students? This is our first class with you. What do we do about the midterm coming up? So you are talking about the tomorrow midterm, Emanuela. Okay, Dr. Nanad, I did not receive exam instructions and exam jet link yet for tomorrow midterm test. Please, do you have practice questions for us? What about them? Okay, I think the so in your midterm will be included 30 questions from embryology and 30 questions from anatomy, because this is body system 1. Okay. So I have sent the diagrams and schematic images of different stages, and that is why I ask you to please pay attention to the figures in the chapters. I think with the figures everything is clear here. Plus so the most part of the questions is multiple choice questions, and hopefully you know what multiple choice questions means. Several possible answers, and you have to choose the right one. Or, and it might be also the multiple answers. Multiple choice question, but with the multiple answers. It is indicated there, it is written there, and you have to choose several right answers in this case. Okay. um, each of this question is as the mark for each per each question is 0.5. So totally 15 15 1 5 are per each subject, and totally the 30 marks you have. This is the maximum for first midterm. For second is again 30, and for final will be 40. What else? So, Malaya, you will receive, I think, instructions. I will apply to administration. Please write to administration or to exam office. I will write too. Okay. So, does this mean we have 60 questions in total for the exam tomorrow? Yes, it means that you will have 60, okay, questions. And you have to be able to to answer the most part of the questions, of course. So another one, maybe you have another questions, please. Right. So you new students, you mean when you join us? Ah, just today. Okay. So in this case, I don't know. This is, I have to ask the administration. I will write to Dean, Vice Dean, Dr. Lana Bokuchava, and I think she is your lecturer in anatomy too and physiology. So I think maybe an additional exam will be appointed for you or something like this, but it should be clarified today, you know, and then we will write you. So please, Emanuela, write me via email to your question. I will CCing this answer to the Dr. Lana, okay? So, is it 1 hour exam? I think it is a little bit more, 1 hour and 15 minutes too. You will receive this all details in the instruction. Um, okay, so they have to write you today. I mean, exam office should write you today. As I know, the duration of the midterm is 1 hour and 15 minutes. I mean, 15. Okay. Still about new students. Are we going to have classes on what we missed? You mean tutorials? Because lectures, they are upload it on the portal, and I mean videos of lectures. But regarding the tutorials, so I don't know. So please write me this via email, okay? About the additional tutorials. So new students, tutorials, additional tutorials. Please write me this question via email, and I will forward this email to Dr. Lana, or CCing this email to Dr. Lana, okay? And we will decide what to do. But it should be done very soon, okay? So what else? What type of questions you have? Okay, in this case, feel free. Still, you have possibility to write the questions, but I will go to the uh, presentation, look, which includes the images. And so which period of development is included in the embryonic period? You have to know that this is a period from 3rd up to 8 weeks. And fetal is from 9th week up to birth. First and second week presentation is not working. Is not working on your drive. Okay. Hamda, please write this via email, okay? I will write down. So first and second week presentation. First and second week. So you mean that video is not working, yes? What about the presentation? I mean, PowerPoint presentation. Have you seen this uploaded on the drive? The presentation is not opening. Okay, that is what I am. Okay, so they are not opening. Presentations. Still not opening. You write me earlier, yes, Hamda? Am I right? And um, and I apply to the admin. I ask them to improve the situation, but it is still not working. Okay, presentations of first and second week. Again. Okay, presentations are not working. Situation with the new students. And additional tutorials. What else? Okay. So the midterm also might just first and second week. Okay, Hamda. Okay. I will clarify this. I will write to the, or I will call them. So I mean IT. department. Um, so what you see here, you see the several images, yes, and you have to be able to identify, for example, what is this one, or what is that one, or what is which stage of development of zygote is this one. Okay. Or for example, you will have this, you might receive this image, and you have to write what type of difference is between these two images. Okay, or what does it mean compaction, compacted and not compacted. Okay, um, so on this here, for example, here you have to magnify this. Okay, you have to be able to identify these different parts of blastocyst. You have to know the differences between the zygote, morula, blastocyst, how they are arranged. I mean, structurally, bilaminar embryo, trilaminar embryonic disc. Okay, and here on this image, you might receive, for example, this uh, schematic image or this real micrograph. And you have to be able to identify here structures of different parts of embryonic disc, okay? As I already told you, these layers, etc. Um, the same is with this image. Or for example, this image might be grouped. For example, um, this one or that one, or and this one, and finally this one, all they might be represented in a one image. And the question might be, for example, in which of these images the extra embryonic mesoderm is formed, not already formed, but is in formation process. So here is the formation of process of formation or of extra embryonic mesoderm. It is formed, and by the way, it gives rise to the chorionic cavity. And here it is already, chorionic cavity is already formed, and the two layers of extra embryonic mesoderm are already differentiated. So this is, here is depicted the process of formation of the extra embryonic mesoderm, and here they are already formed, these two parts of extra embryonic mesoderm. So here the extra embryonic mesoderm is already done, okay, together with a chorionic cavity, of course. So chorionic cavity is also in the process of formation here, but here it is already done, okay? So is it understandable? My email address, my email address. So my email address is, I will write you, okay? Correct? New Vision G. Yes. Look. Um, and please think about all these questions a little bit earlier. I'm not talking about the new students, of course. They join us today or few days ago, so their situation is a little bit different. You know, the main problem usually is because you have the midterms and final exams in several subjects simultaneously. This is not easy to be well prepared for all these subjects. That is why you have to start reading and questioning much more earlier. Okay, in this case, your learning process will be much more effective if you read. Unfortunately, the time of, I mean, students, when you are students of universities, medical universities, this is totally uh, different style of living. I mean, it differs from other students. You know, the medical school students all the time have a lot of things to read, to study, and especially when the teaching and learning process is the integrative, it is really not easy. You have to prepare, for example, in the life science one, you have molecular biology, biochemistry, and cell biology. They have, for example, for final. And in the case of body system, you have anatomy and histology, and then in body system 2 the physiology will be also introduced. In body system 1 also physiology will be introduced, so please don't waste your time. Read as much as possible. Okay, so maybe another questions. Okay, I think I have told you everything what I want to clarify. Pay attention to the um, images in textbook, as I already told you. I mean figures and pages, okay, which are indicated. So, guys, I'm done. I can finish my lecture. I have used your 10 minutes of break. Now you can take a break and then go to the next lecture. You have now anatomy, yes? Okay. Please, you know my email, and write me, okay? I think with the embryology now everything is clear, and it is not so difficult as the first impression is. Okay, guys, good luck for tomorrow, and meet you next week. Feel free, write me. You know my email, okay? Bye. Thank you for attention.